Sometime this November, a spacecraft launched before most people alive today were born will cross an invisible line. That day on, a radio signal sent from Earth, traveling at the speed of light, will take a full 24 hours to reach it. Ask it a question today. Get your answer the day after tomorrow. This is Voyager 1. It is running out of power, held together by engineers performing surgery across 16 billion miles. And when it finally falls silent, its journey won't end. It will have barely begun. September 1977, Florida. A Titan Centaur rocket climbs into the sky carrying a machine built for a 5-year mission. The timing wasn't chance. Once every 176 years, the outer planets align so that a single spacecraft can slingshot from one to the next. NASA called it the Grand Tour. Voyager 1 swept past Jupiter in 1979 and Saturn in 1980. It sent home images that rewrote textbooks, volcanoes erupting on Io, and the intricate braids of Saturn's rings. And it did all of this with hardware that today sounds like a joke. Its computers hold about 69 kilobytes of memory combined, less than a single photo on your phone. Data comes home on an 8-track tape recorder. Its transmitter broadcasts with about 20 watts. By the time that whisper reaches Earth, it is billions of times fainter than a watch battery, and we still hear it. Bolted to its side rides something stranger than any instrument, a gold-plated record. Greetings in 55 languages. The sound of rain. A heartbeat. 90 minutes of music. Carl Sagan's team designed it as a message for anyone, or anything, that might one day find it. A bottle thrown into a cosmic ocean. In 1990, past Neptune's orbit, Voyager turned its camera home one last time and photographed Earth as a pale blue dot, less than a pixel wide. Then the cameras were switched off. Forever. There was nothing left to see. Voyager 1 is powered by decaying plutonium, a nuclear battery with no moving parts and no way to recharge. Every year, it loses about 4 watts. That's the entire mission now, a countdown measured in watts. When they launched, the generators produced 470 watts. Today, less than half of that remains, and every heater, every instrument, every heartbeat of the mission must fit inside what's left. For decades, engineers have been rationing that power. Heaters, sacrificed. Backup systems, sacrificed. Instrument by instrument, they are switching off pieces of the spacecraft to keep its heart beating. In February 2025, the cosmic ray detector went dark. In April 2026, engineers shut down the charged particle instrument that had run almost continuously since 1977. Operating this spacecraft has become an exercise in patience that borders on the surreal. A command sent from Earth takes 23 hours to arrive. The confirmation takes another 23 to come home. When engineers shut down that instrument in April, they pressed send, and then waited nearly 2 full days to learn whether it had worked. In February, during a routine roll maneuver, Voyager's power levels suddenly dropped without warning. Nothing on this spacecraft is routine anymore. Every anomaly could be the last one, and every fix is performed from a distance no repair crew will ever cross. Of 10 science instruments, 2 remain, a magnetometer and a plasma wave sensor. The last senses humanity has in interstellar space. Think about what those 2 remaining sensors are doing. They are measuring magnetic fields and plasma waves in the actual material between the stars, a region no instrument on Earth can sample. This isn't legacy data from an old mission. It is frontier science, produced by hardware older than the personal computer. Because that's where it is. In 2012, Voyager 1 crossed the heliopause, the boundary where our sun's influence gives way to the space between stars. It is the farthest human-made object in existence, over 25 billion kilometers from home. No other working machine has ever sampled that region. Every day it survives as data no one has ever had. And this year, the team is attempting something remarkable, a last resort power strategy. They call it the Big Bang. switching off a group of aging, power-hungry components all at once and replacing them with lower-power alternatives, keeping the spacecraft just warm enough to live. The stakes are brutally simple. The reconfiguration could free up perhaps 10 precious watts. But if the spacecraft's fuel lines freeze in the process, Voyager can no longer point its antenna at Earth. And a spacecraft that cannot point home is not a mission anymore. It's debris. There's a detail in this plan that tells you everything about the people running it. When they shut down that particle instrument in April, they left one tiny motor inside it running, half a watt, so its mechanism wouldn't seize in the cold, just in case, someday, they find the power to wake it up again. They're testing it on Voyager 2 first, the safer twin. If it works, these machines might keep doing science into the 2030s. If it fails, the mission could end with a single unanswered command, sent into a 24-hour silence. But here is the part almost nobody talks about. When the power finally dies, nothing stops. There is no friction in interstellar space, nothing to slow it down. Voyager 1 will keep traveling at 17 kilometers per second for millions of years. In about 40,000 years, it will drift within 2 light-years of a small red star called Gliese 445. By then, no one may remember it exists. The golden record was built for that timescale. Gold-plated copper, sealed under a cover electroplated with a sample of uranium, a radioactive clock that any finder could read to calculate how long the craft has traveled. In the vacuum of interstellar space, the record should remain playable for over 1 billion years. Think about what 40,000 years means. 40,000 years ago, humans were painting animals on cave walls. Every civilization we have ever built fits inside a fraction of that time. The pyramids of Giza are 4,500 years old, and we call them ancient. Voyager's journey to the next star is 10 times longer than all of recorded human history. It is the longest thing we have ever planned. Space is so empty that the odds of Voyager hitting anything, a star, a planet, even a grain of dust large enough to destroy it, are effectively zero. It will orbit the center of our galaxy, a silent passenger, for billions of years. It will still exist when our sun swells into a red giant and consumes the Earth. The golden record, the rain, the heartbeat, the music will likely outlast the planet every sound on it came from. The engineers at JPL are not just keeping an old spacecraft alive. They are finishing humanity's longest letter before sealing it and letting it go. Some of the engineers maintaining Voyager today weren't born when it launched. They learned programming languages that universities stopped teaching decades ago just to speak to it. When this mission ends, it won't be because anyone gave up. It will be because physics, finally, said no. Sometime in the next few years, a final signal will crawl across one light day of emptiness, and no reply will come. The mission will end. The journey won't. Long after the last human voice has faded, a machine built in 1977, carrying the sound of rain, will still be out there, falling forever through the dark. If this story moved you, consider subscribing. There are more like it.